All right, we are starting a new chapter, chapter 4, and we're skipping through a few sections, but I still want to give a brief review of what is the start of chapter 4 before we go on to the section that we're going to look at today. One of the things that we talked about in the beginning of chapter 4 is the difference between prime and composite numbers. Prime numbers are only numbers that can be divided by themselves in 1. That'll get an integer. Composite numbers are the ones that you can divide by any other number, and you can also get an integer. For example, like 32 would be a composite number. 17 would be an example of a prime number. Other things that they dive into is equivalent fractions. So like if you said you had 1/2, for instance, an equivalent fraction of 1/2 would be 2/4 or 3/6, something along that nature. It's when you multiply or divide both the top and the bottom by the same value to get an equivalent fraction. And what I have in front of you is factors of a number and prime factors of a number. For this case, I chose 32. And the factors of a number are values that you can multiply by to get that said number. So if you look, numbers that I could use to get 32 is 1 multiplied by 32 will give me 32. 2 multiplied by 16 will get me 32. 3 won't, but 4 times 8 will get me 32, and I think those are it. So if you're going to list the factors of 32, it's like 1 comma 32, 2 comma, and then 16, and then 4 comma 8 comma. So these are the lists of the factors of 32. If you're looking for the prime factors of 32, you have to use what is called the factor tree. So the factor tree looks like this. So you're kind of going to make a little branch off of 32, and you're going to determine two values that you can multiply by 32. And I'm going to use 4 and 8. And I look at those two, and I identify if those are two prime numbers. They are not. So I can go further. I can go 2 times 2. Here I can go 2 times 4. And here I can go last again 2 times 2 until I have prime numbers at the end of each of my trees. So I'm going to circle these to identify that these are prime numbers, and the value that I get for this is 2, and it's 1, 2, 3, 4, 5. So it's 2 to the 5th power. So 2 to the 5th power will end up equaling 32. Last thing is the multiples of 32. So it's basically what you're going to do is if you multiply 32 by 1, you get 32. If you multiply 32 by 2, you get 64. If you multiply 32 by 3, you get 96. 32 multiplied by 4, you get 128. 32 multiplied by 5, you get 160. And so on and so forth. So that's what it means for multiples of a value. Going into the lesson, we're going to talk about, in section 4.5, the rules of exponents. And we are going to be giving you two rules today. The first one is shown in front of the screen, and it's called the product of powers property. The product of powers property states that to multiply powers with the same base, all you have to do is add the exponents. Now, when they mean by the same base, if you look up at the example that they show, it's a cubed multiplied by a squared. Your base in this case is a. If you have the same value, you can then add the exponents together like so, and it means that in this particular example, it's a to the 5th power. So if we look at these examples, I want to find the products of the following. Write the answer as a power. So don't evaluate it as just a specific numerical value. I want you to have a power in front of it. So this is kind of how I want you to show it on your works and homeworks, tests, and quizzes. So if we go equals, the base in this case is 2, and since they have the same base, I can add the exponents, which then gives me 2 to the 5th power. The second one, they have the same base of 4, and now I can just add the exponents. I can do a 6 plus 4 plus 3. So this is 4 to the 13th power. Last one, I have the same base of 5, and this is where it's kind of tricky. Even though there's no exponent on that left 5, it's actually 5 to the 1st power. So when you add the exponents together, it's going to be 5 to the 1 plus 2 power, which equals 5 to the 3rd power. The next rule that we're going to talk about when we have rules of exponents is the quotient of powers property. So now this states that to divide powers with the same base, you're going to subtract the exponents of the denominator from the exponent from the numerator. So if you look at this top value here, I have a to the 5th power divided by a squared. So since they have the same base, all we have to do is take 5 and subtract it by 2, which gets us a to the 3rd power. This is the easiest way to do this, much easier than this method that's shown here. Okay? So again, I'm going to write these answers as a power. And if I look at this one, I have the same base of 6. And so since I'm dividing these with exponents, I can subtract the said exponents. So this is going to be 6 to the 5th power. Looking at this example, I have the same base of z, and so all I have to do is 8 minus 3, which equals z to the 5th power. Last one on this page, same base of 10, which means I have to take the bases and subtract them, which equals 10 to the 4th power. Now, there are going to be some problems in your homework where some of which are going to have the same base and some of which they are not. So what you have to do is, if they don't have the same base, such as if they're in a numerical value, first thing you're going to do is simplify it and get those numbers into lowest terms if you can. Then you can worry about the values with the same base and perform either the product's powers property or the quotient powers property. So for this first one, I have 12n cubed divided by 8n squared. So the first thing I'm going to do is I am going to try to reduce this 12 over 8. And I can divide both values by 4. So 12 divided by 4 gives me 3, and 8 divided by 4 gives me 2. So now all I'm left with is n cubed and n squared in my fraction. So now that I've taken care of reducing those numerical values and getting lowest terms, now we can take a look at the exponents with the same base. Since I have a base of n and I'm dividing those, I can take n and go 3 minus 2 all over 2, which then this equals 3n, because it's 3n to the first power, all divided by 2. Looking at the second one, I can see that I have a different base of 13. And there's no other value there, so that is in lowest terms. So now I'm going to worry about the values that have the same base. If I look at the top, I have b to the 4 multiplied by b to the 4. So what I'm going to do is I'm going to use my products powers property. So I'm going to go 13, and I'm going to go b to the 4 plus 4, which equals 13b to the 8th power. But I still have this b in the denominator. They still have the same base, so I can go 13 to the 8, or to the b to the 8 minus 1, which then gives me a final answer of 13b to the 7th power. Okay? Looking at this example here, 2m to the 4th multiplied by 7m to the 5th, what I'm going to do now is I'm going to multiply this 2 and this 7, which gets me 14. And then I look at these two here, and they have the same base, so I'm going to say m to the 4 plus 5 power, which gives me 14m to the 9th power. Last example on this page, I look at it's 12y squared multiplied by y to the 8th divided by 16y to the 5th. I look at the numerical values, and can I reduce them? I can divide them both by 4, which would get me 3 on the top and 4 on the bottom. I'm just filling in the variable. And so now I can go 3y to the 2 plus 8 divided by 4y to the 5th. This gives me 3y to the 10th power divided by 4y to the 5th. Now, since I have the same base of y, I can use the quotient property. So it's 3y to the 10 minus 5 all divided by 4, which then equals 3y to the 5th power divided by 4. Here are some practice problems that you can take a look at. One of which people had a little bit of trouble on was this one. And if you look at it, all you're going to do is multiply the p's together, which makes it p to the 3 plus 4 power, which gives you p to the 7th power. And then q, which is 2 plus 2, which makes it 4. Okay? Another one that's kind of interesting is this one right here. Is we don't know what this exponent is, but what we do know is that we have to add some value of x plus 6 to make it b to the 10th. And the only thing that could possibly be is 4. Same thing goes for this one over here. The value that must equal over here must be 8, because 8 minus 3 will give me 5. And that is being able to apply the rules of exponents. I hope this helps. Until next time.